Okay, hi everybody, and thanks for joining us today. My name's Robert Yen, and I have with me today Klaas Bootsma. Klaas is the lead author of New Century Maths, and I'm the publisher and the series editor of this series. So what we're going to do today is we're going to go through the new mathematics syllabus, 7 to 10 in New South Wales, and we're going to do a deep dive and have a look at it quite exhaustively, I guess, so that you can see what's changed and what's been moved around. So I've got my email address there, and I've also got our website, and you can find out more information, or if you've got any questions. Do you want to say anything, Klaas, before we begin?
No, that's just good. I'm okay. I'll just let you start, Robert.
Okay, sure. Okay, so a bit of background. So the Mathematics K-2 syllabus was published in 2021, and it's actually being implemented this year. And then in 2022, so last year, in March, the draft 3 to 10 syllabus was published by NESA. And also in last year, in May, the ACARA published their revised Australian curriculum. And then, surprisingly, in August, NESA published a second draft of the years 3 to 10 math syllabus. And then finally, in December, they published the final version. So what we're talking about today will be based on the final version. And then this year, as I said, the K-2 syllabus is implemented. And then next year, the years 3 to 10 syllabus will be implemented. However, it doesn't necessarily mean all years 7 to 10 will be implemented together. So just to let you know, and I've deliberately snipped this from NESA and from the Department of Education so that you know that this is fact. So on the NESA website, and also in the syllabus, it says school sectors are responsible for implementing syllabuses and are best placed to provide schools with specific guidance and information on implementation given their understanding of their individual circumstances. So in the past, everyone started with years 7 and 9 first, and then years 8 and 10 the following year, because that makes the most practical sense. It's a stage-based syllabus. But for the first time, NESA's decided that each of the sectors can decide how they implement it, how they phase it in. And I know some schools are trialling the new syllabus this year so that they can get used to it straight away. Now, on the bottom half of the screen, I've got what the DET has instructed government schools to do, and that is to do it how it's been done traditionally. So next year, 2024, implementation for years 7 and 9. And then 2025 will be implementation for years 8 and 10. And that's basically because it's a stage-based syllabus, and you can't really implement a new syllabus halfway through a stage. Now, I've also been asking around the Catholic schools and the independent schools, and this is what I've heard, but I don't have it in writing. So Catholic schools are recommending the same implementation timeline, whereas independent schools, I guess that's why they're called independent schools, it ought to be a local school decision. Okay. Also coming soon, the revised syllabuses for years 11 and 12, so for the HSC course. So we expect to see some draft syllabuses this year, and then final syllabuses next year, and then it'll be implemented in 2025. And then the first HSC exam in year 12 in 2026. So there's a lot of curriculum change coming up. Okay, I have some questions for you, Klaas, because you and I, because we work with textbooks and publishing and writing, we've been studying this maths syllabus quite intensively this year. So I've got 3 questions to ask you. Question 1 is, has the syllabus content changed much?
I don't think it's changed all that much just from what we've done. There are a few things that just deleted, but on the whole, I think it's much the same as what it has been. The good part about it, I think, is maybe this is not with content, more with the third question. We don't have a separate thing for stage 5.1, 5.2, 5.3 anymore. Instead, we've got a core and a pathways. One thing about the old syllabus, there was a lot of work in there, and especially with the extension or the advanced students, they probably wouldn't get to the final thing. So they've decreased the content and gotten rid of some things that probably did not need to be there.
Yep. And about 3 years ago, in 2020, we actually published new editions of New Century Maths because, well, it was time. And we also wanted to update the content according to what we thought would change in the syllabus. We knew the syllabus change was coming. And we also knew that we had to align it to the new the stage 6 HSC syllabuses.
Yeah.
So we did that in 2020. And then this time, that's saved us a lot of work because this time round, we just have to update it with the new topics such as networks.
Yeah, and that's why I said the content hasn't changed much, because we did that review of the books 3 years ago.
Okay, next question. Why did it need to change?
I think it's too much work in it, too cluttered, a lot of unnecessary things in there. And you had the stages, and that really put students in different levels straight away from the word go. And there wasn't much movement for students to change levels at all. I think that's a big factor.
Yep. Okay. And it's also been, I think, 10 years this year since the syllabus was last changed and the new Australian curriculum came in. So it was time for a change. And also, I think we also got to the stage where a lot of schools weren't getting to the harder topics in year 10. So we had a lot of students who were unprepared for advanced maths or extension 1 maths because there was just too much content there.
Yes.
And finally, Klaas, what do you think of the new syllabus?
I printed the latest version again. The latest version has been the March 2023, and I've looked at it again. They've actually split the content and the teaching advice into 2 separate documents. It's pretty clear that you have all your core done first and then your pathways. I just like the layout. There's heaps of examples that they've put into the syllabus, and the teaching advice links the maths course to other subject areas and also to the other maths courses in senior years, which is a really, really good idea. And another thing I like about this new syllabus, they give non-routine problems, examples of non-routine problems, which is good for problem solving in the course.
Okay, that's great. I think we're going to have a look at some of these things in a minute. We should also acknowledge that there was a New South Wales curriculum review in 2020, and this was one of the reasons that we are having this syllabus changed. So it's not just maths that's being changed, it's all the subjects. Really important that we look at how the value and importance of maths in the New South Wales curriculum. And we also have a change in the Australian curriculum. So there's a lot of changes, and this new syllabus also has to be aligned to the Australian curriculum as well. Now, when Professor Jeff Masters did the curriculum review in 2020, he found 4 things. He discovered 4 findings. One was that our maths achievement levels are declining, and especially for our lower achieving students, they're being left behind. And I think part of the problem with that is that teachers are struggling to complete all the dot points in the curriculum. And so they're not spending enough time training those lower achieving students up. And there's also the maths teacher shortage as well. So, and I guess you've got to factor in the pandemic as well. And then the other finding was that our syllabuses are overcrowded and inflexible. So they're too easy for some students and too hard for others. So it's accidentally promoting a tick box approach to teaching dot points rather than deep maths. And also there's up to 6 years difference in abilities in each year level. So how do you write a new syllabus that solves all those problems? Well, this was the recommendation. The main one was that new syllabus is not just maths, describe core learning in each subject area, stripped down to focus on what is essential. Knowing what is core will ensure teachers can have the flexibility they need to teach to a variety of different student abilities within the one classroom. So, and also there is going to be a focus on numeracy, literacy, and early years foundations in English and maths. So let's have a look. I should say to you, audience, that there's a lot of PowerPoints that we're going through, and there's a lot of text, but we're not going to read our PowerPoints. We're just going to leave it up here for you to read or pause the video, and we're just going to, I guess, pick out and mention things to note. So what do you notice there, Klaas, the features of the new syllabus?
The core knowledge and skills, focus on numeracy, the big ideas, core knowledge and skills. And also the next point, the routine and non-routine problem solving. I think they're really important. And the second last one, examples and diagrams are included in the syllabus. It's more instructional, and that can help teachers that aren't maths teachers. And the big thing is, of course, at the last point, we don't have the 5-1, 5-2, 5-3 anymore. It's just core versus path.
Yeah, so the thing about core versus paths is that core is what everyone should know, everyone should learn. So those students who are struggling, you can just focus on the core and try to build them up. And then those students who are often bored in years 7 and 8 and already know a lot, like they know their maths really well, then there's the option of extending them from stage 4 and to stage 5. And there's even the opportunity to teach them all the topic areas. Okay. Okay. So, all right, let's just keep moving on. So here's an example of what the old syllabus looks like. Now, I like the old syllabus. I'm not saying that it was bad. It was a pretty good syllabus, but I think the new one is an improvement on that anyway. So the old syllabus, you'll notice that it's got like a content description, and then it's got the Australian curriculum code, and then it's got a dot point under it that elaborates on what needs to be done. Okay. Now this new syllabus looks like this. What do you notice here, Klaas?
The colouring in for a start, that sort of stands out. So it draws you to the examples in that way. It's also got a graph in it. So they've actually shown a graph. And they also quite often say using technology. So they don't have a little icon there that sort of people miss all the time. So I think that's pretty important. But it's the graph, and yeah, it's the layout. It's much better. They've got the table of values for the graph. It's really good, that. And then they've got down the bottom, recognise quadratics and exponentials in real life contexts. So they try and relate it to what we see in the real world.
Yeah, so the new syllabus provides those examples in the grey, that's in the grey shading. But one thing that I noticed straight away was their dot points are usually one line, like they don't go over one line. So they're very sharp and succinct and explicit. You know exactly what you want to teach, or what you have to teach, I guess. Okay, so here's another page. Okay, so I was going to say the new syllabus is less wordy, but it's actually probably more wordy, but it's meaningful dot points that spell out exactly what needs to be done. Okay, so with stage 5, we have that core versus path structure. And the reason for that is now it opens up the flexibility in programming. So we can have pathways for students who are struggling. We can have pathways for your standard student, your average student, I guess. And you can have pathways for your students who are, I keep coming back to the word advanced, or who are high achievers, I guess. And then any of those pathways in between as well. I also we've had 5.1, 5.2, 5.3 now for 20 years.
Yes.
And I don't think it was a bad thing. It was actually a good thing. But over time, people just started thinking of them as 3 separate courses and streaming the classes into those courses, to the point where at a presentation day at the end of the year, you would have a student get a first prize in 5.1, which really goes against the whole idea of a stage 5 continuum. Okay, so 5.1, 5.2, 5.3 were really meant to be points on a continuum rather than boxes. So we're going to try to, hopefully the core versus path structure will discourage students and teachers from teaching in boxes. It's also to encourage aspiration in students. So we should take students as far up as they can go, depending on where they are, because we are not, you know, like I said before, we are not doing the best for our students who are struggling, but we're also not doing our best to our students who are achieving. So this core is actually more than stage 5.1. It's a bigger core. It's up to the middle of stage 5. And in the final version of the syllabus, it says it's foundation for mathematics standard 2 in stage 6. So that's what we're aiming, you know, the average student, well, we're aiming the average student to get towards mathematics standard 2 in stage 6. So core is like the standard, and then paths make up the balance of the course, including the topics that are heading towards the HSC maths courses. And you'll see that the paths, they're all labelled according to math standard or advanced or extension. Yeah. And the stage 5 paths you could be taught before year 9 to more capable students. So thinking back to those advanced students that you get in year 7 and 8 who often get bored, you can start teaching stage 5 work in year 7 and 8. Do you have anything to add, Klaas?
No, I think that last point is really important, that you can start teaching the paths before year 9 to capable students in year 8.
Okay, so here's an overview of the of stage 4 and stage 5, the outcomes. So you've got the core in this column, and you've got the 3 strands, number and algebra, measurement and space, statistics and probability. Okay, so it's not measurement and geometry anymore. It's called measurement and space, and that's the same as what it is in the new Australian curriculum as well. So you've got the stage 4 and 5 broad topics here. They are all pretty familiar. Nothing looks new to you and me. And then when you get to stage 5, there are those paths, some of which that lead to math standard, some of which lead to maths, most of which go towards maths advanced.
Yeah.
And I think the only new one here is introduction to networks. Everything there is similar to what we're currently teaching. Okay, so here's an example of a progression of a topic area. So this is the topic called Pythagoras in trigonometry. So in stage 4, it's just Pythagoras' theorem. So there's the outcome for stage 4. Then stage 5 trigonometry part A is stage 5 at its core. So it's just basic right angle triangle trigonometry. And then trigonometry B is also core, but it's stuff like bearings and angles of elevation and depression. And then trigonometry C is a path. It's actually a standard and advanced path. That means it's useful for students who are heading towards standard or advanced. Now, I was going to say recommended, but I don't want to use that word because you don't have to do it. Because if you're a standard student, I actually wouldn't recommend you doing sine, cosine, and area rules because they'll get it all again in year 12.
Year 12.
When they're ready for it, I think. So, yeah, so trigonometry C is a pathway that does Pythagoras' theorem and trigonometry in 3D, and also the sine, cosine, and area rules, including bearings. And then finally, trigonometry D is what we teach in year 10 to those advanced students going towards maths advanced, and they're the trig functions and trig equations. So the idea is for schools to select enough path topics as appropriate. So you don't have to select them all, even all the recommended standard ones or the recommended advanced ones. You don't have to select them all. You've got to select enough as appropriate. So we've got to, I guess you've got to lift your students to an appropriate level. Okay, so that's the progression of this area. So all the other topics have like an A, B, and C as well.
Can we just go back to that, Robert?
Yep, sure.
In the syllabus, people have to realise that all the core topics are done first when they look at the syllabus document, and then the paths begin after all the core's been covered. So what we've done here is put all the trigonometry together, the A, B, C, but you don't find that in the syllabus.
Yep. So I guess this is a good time for us to talk about navigating the syllabus and how difficult it can be. What I did, I mean, it's an online syllabus, but what I did, I downloaded it into a PDF straight away so that I can have the full document that I can read from page to page, from start to finish, so that I don't miss out any pages. But maybe I'm old school, I don't know. Okay, so as I said before, these are the content strands. They're the nouns of the syllabus. And then we've also got the working mathematically processes, or the verbs, and they are now embedded in the content. So we've got understanding, fluency, problem solving, reasoning, and communicating. Okay, so you can read these later, but we've got the top, what's on the top is how we've defined understanding at the front of our books. So understanding is deep understanding, seeing how mathematical content is interconnected. And then on the bottom there is some examples from the syllabus on how or what understanding is, and also how it's integrated into the content, the actual syllabus content descriptions. Next one is fluency. So it's applying maths. So if you're fluent in a language, you know how to speak it well. You know which word or phrase to use. So same with maths. You know exactly which kind of maths, which skill, which procedure to use. And so, for example, describe and apply Euler's formula for planar graphs. So that's for the new topic networks. And then we've got problem solving, interpreting a rich problem, selecting appropriate strategy, and then solving the problem and communicating and justifying the solution. Okay, so there's some examples from the syllabus. And I think the important thing with working mathematically, that what the syllabus says is you need all these 5 processes to become a good math student. You can't just understand and be fluent. You've got to be able to use your knowledge to solve problems, including non-routine problems. So, you know, you're a good math student if you're not just because of your knowledge and fluency, but because you know exactly what to do in an unusual situation. Then we've got reasoning, which is using higher order thinking and to generalize and prove things. So from the syllabus, it says students appreciate that mathematics makes sense and can be understood. They develop an increasingly sophisticated capacity for logical thought and actions. Yeah, okay. And then finally, communicating, which is describing and explaining maths. And the syllabus says encouraging students to reflect on and discuss the strategies they use, assists them to learn to work mathematically. Students learn to think more. And an example of that is explaining that a length recorded as 10.2 centimeters would have an absolute error of 0.05 centimeters, and that the true length could lie between 10.15 and 10.25 centimeters. So that's from the new topic. That's absolute error and percentage error is new to the syllabus as well. So it's just showing you how all 5 processes work together to help students become have a deeper knowledge of mathematics. So what's also happening with the syllabus is every page has this working mathematically outcome. So it says a student develops understanding and fluency in mathematics through exploring and connecting mathematical concepts, choosing and applying mathematical techniques to solve problems, and communicating their thinking and reasoning coherently and clearly. Now, it's on every page because it's in every topic from years kindergarten to year 10. So that is why we have only one working mathematically outcome, because NESA, the syllabus writers, have understood that these processes can't be split apart. They're all integrated. Okay. Oh, so this, as Klaas said, there's teaching advice in the syllabus now. Do you want to talk about this, Klaas?
Yeah, I find this really good too. if you look at the document and download it, it's actually two parts of it. There's your content and there's your teaching advice. The teaching advice just gives you all the terms that you probably need to look at, but don't just rely on the teaching advice. You really make sure that you look at the syllabus, the content part as well. And I just like the fact that it's got key ideas, key terms, basic knowledge, background knowledge, and then the making connections and the non-routine problem solving. And hopefully teachers will not ignore this part of the syllabus.
Yep. And at the other extreme, hopefully teachers won't try to teach everything that's on this page.
Yeah.
This is advice and recommendations, suggestions, and ideas. The syllabus is the syllabus. So this is just to help you, give you guidance. So yeah, it's teaching advice. So it's giving you guidance on how to teach Introduction to Networks.
No, so say one more thing about the syllabus here. I've had a look at it again today. And if you look at the network topics, you can actually bring up the network topic and it'll give you the content and it'll also give you the teaching advice together.
Oh, okay.
And so that's on the board side, on the NESA side.
Yep. So that's the advantage of having an online syllabus, because there are links there that will you can click that will take you to everywhere. Also, there's a section here called Making Connections, which tells you how networks can be applied in other subject areas, as well as in Stage 6. So obviously Mathematics Standard is here because it's covered in the networks topic there as well. Yeah. And then there's also some ideas for non-routine problem solving there also. So the important thing to remember is this is, I guess, part of the syllabus, but it's not actually, you don't have to teach everything here.
Maybe they should underline the word advice.
Well,
teaching advice, yeah.
That's correct, yeah. Because one of the problems some of us maths teachers have is that we try to teach to dot points rather than teach the big ideas in mathematics. Okay, now we're going to unpack the syllabus content. So there's going to be a lot of dot points coming up now, and we're going to start with Stage 3 and go all the way to Stage 5, because as high school maths teachers, we're also teachers of Stage 3. Not many students come to high school completing Stage 3. So we reflect that in our teaching, and Klaas and I also reflect that in the New Century Math series. Yeah. And we're gonna present things different order than what's in the syllabus, because the syllabus jumps all over the place. I mean, no, the syllabus does have an order, but it's not really, doesn't really show the progression of things. So we're going to take one topic or one content strand at a time, and then we're going to show the topic progression. And we're just going to highlight the changes, and we're not going to read all the dot points. As I said, you can pause the video, or you can read while we're talking. So first of all, the first topic, or the first strand, content strand, is number and algebra in Stage 3. And the headings, or the topics, have these unusual headings because they come from sort of academic research on how primary school children learn. So additive relations means adding and subtracting processes. And then the top one is representing numbers. So there's a lot of research behind the syllabus about when it's the best time for students to learn particular things. So all the cognitive research and all the education research has gone behind this. And Klaas, you might remember Peter Gould that we used to teach with, or he's behind a lot of the work that's being done around here, as well as the work of academics. Yeah. So representing numbers is whole numbers, decimals, integers. So students do learn in Stage 3 integers, negative integers on a number line, and then fractions, decimals, and percentages. And then with adding and subtracting, they learn adding and subtracting whole numbers, adding and subtracting decimals up to 3 decimal places, and word problems. Okay. And then multiplicative relations is multiplying and dividing. So what have we got there? Well, I'll leave you to have a look at that, but we will talk about things like what's been removed, square and triangular numbers, and the lowest common multiple. And the highest common factor has also been removed and moved to stage 4. And also dividing decimals by a 1-digit number. So it's been removed altogether. So I'm guessing that students are allowed to use a calculator to do stuff like that.
Mm.
But everything else there, all those operations there, and all that pre-algebra stuff in the last 3 lines, they are still there. Like, that's not different to what primary school students do. Okay, fractions is next. So pretty much the same, other than denominators of 12 and 100 have been removed. So anything to add, Klaas?
No, not on this. So that's quite clear.
All right, let's go on to stage 4. So now we look at still number and algebra. So the integers topic has not changed at all, nor has the fractions, decimals, and percentages topic. What has been taken out of the syllabus is lowest common multiple. I would still teach it to your better students because it does come in handy in adding and it's
Adding and
simplifying.
subtracting.
Adding and subtracting. Yeah, adding and subtracting fractions, including algebraic fractions.
Yeah.
But as you were saying the other day, Klaas, I think we often, if students find that hard, that you just ask them to multiply the
yeah, it's quicker.
Two denominators together, so you don't have to use the lowest common multiple.
No.
But anyway, that's a teacher and a class decision. And then also new is the concept of rational versus irrational numbers, and ordering them on a number line. So the whole concept of what a rational number is, which I remember like 20 years ago, we used to teach this anyway. So, but that concept of a rational number was only taught to 5.3 students, I think.
Yeah.
Okay, ratios and rates. Again, the usual suspects there. Converting between rates has been moved back into the syllabus from stage 5. I remember 10 years ago it was in the syllabus, like in the last version. It was taken out and now it's been put back in. And informal graphs to model familiar events such as the noise level of a classroom or the level of water in a bathtub. That was put into stage 4 and now it's been taken out again. I think it's in stage 5 now. Okay, algebraic techniques, no colors here because it's your usual algebra stuff. Nothing new there, nothing to see. All right, indices, the same. There's only one new index law, but it's nothing exciting or controversial or new. It's actually just AB all squared equals A squared B squared. With equations though, they've decided that what's core now is just 2-step equations. So these are the types of equations in the syllabus that we are going to teach in stage 4. So we're not going to do the harder equations with variables on both sides unless it's one like this where you can solve in 2 steps. So 3-step equations has gone to stage 5 core, including those equations with brackets. But again, I would teach it to students who are capable. So we have kept it in the textbook, in the Year 8 textbook, as extension work. And also equations and formulas has been moved back into stage 4 from stage 5. Again, in the last syllabus, it was in stage 4, was moved out, so it's been moved back in.
Yeah.
So equations and formulas is substituting values into a formula to solve an equation. Okay, linear relationships. So this is plotting points and lines on the number plane. Okay, so what's gone? So translations, reflections, rotations, and the number plane is gone to stage 5 path because it's more relevant there. Teaching it at stage 4 students doesn't really have any application until you start looking at transformations of functions. And what's been removed or moved to stage 5 is graphing simple nonlinear equations. So it's only linear equations in stage 4. And also something that's new is applications of linear equations. Okay, now we're up to stage 5, number and algebra still. Nothing's changed other than the formulas. And we knew these were going to change because in Maths Standard, simple interest is I equals PRN. And compound interest is FV equals PV 1 plus R to the N. Whereas in the old syllabus, in junior syllabus, it was A equals P 1 plus R to the N. So we've updated the formulas. And if you're actually using our previous edition, like our current editions of New Century Maths, you'll notice that we had actually updated those formulas to these anyway. But now it's official. So these are some of the subtle changes. Okay, what is it? Stage 5 algebra core. So we've got operations of algebraic fractions is core, and expanding binomial products is core. So that's a pretty difficult core. Now, the Australian curriculum has actually removed algebraic fractions from its curriculum. It's actually now a year 10 option topic. So that's just an aside to let you know. So that's where the core ends with algebra. So everything the rest of the page is algebra that's path and recommended for students going to advanced. So you've got the harder algebraic fractions, you've got the factorizing monic quadratics, and I'll get you to read the rest, special binomial products there. Okay. And then we've got indices core. For stage 5 core is index laws, zero index and negative indices. And then for path, we've got negative indices for algebraic bases. We've got fractional indices. Now here's something unusual, converting recurring decimals to fractions, but using digital tools. Now that's pretty easy. You just type into the calculator and it'll tell you the answer, won't it?
It's about time they did that.
Yeah. So you can still teach the algebraic way, but as an interesting application, I guess. But this makes it really easy.
Yeah.
And then there's that third topic at the end, which hasn't changed. And rationalizing the denominator. The denominator has always been C root D, not a binomial.
Yeah.
Not A plus B root D. Okay. So equations, stage 5 core equations. Now this is where the 3-step equations kicks in. And also equations involving just one algebraic fraction and equations and formulas.
Yeah.
And then path equations, stage 5 path for advanced students, quadratic equations, monic ones first, and then simple cubic equations, and also solving linear inequalities. And then we come to equation C, which is also advanced, and you can see the algebra is getting really harder now, but not different to what we are used to. So the only change is that, well, you've got the harder algebraic fractions that you can see on the screen here. And there's something new that I think we currently teach in our old books anyway, looking at when you're solving a quadratic equation using the quadratic formula, looking at when you get unreal roots and equal roots. So basically examining the sign of the discriminant. And with simultaneous equations, okay, some of us teachers do this already, but looking at what happens when you have parallel lines, that means there's no point of intersection, there's no solution to the simultaneous equations. And what happens when you have the same line, like two linear equations which reduce to the same line, then it has an infinite number of solutions. So that's been explicitly added to the syllabus now. Okay, we're still stuck in number and algebra because it's a big topic.
A long topic, yeah.
Linear relationships, and the other topics aren't that long. Linear relationships, what's core, distance, midpoint, gradient, but not the formulas. Graphing lines, y equals mx plus c. Notice it's plus c now because it used to be plus b, but we've updated it for the senior maths as well. Applications of linear equations. Okay, equations of parallel and perpendicular lines. And then what's path? Again, it's nothing unusual. It's what we're currently teaching in 5.2, 5.3. So what is different is that graphing lines by finding intercepts is no longer part of the syllabus. You can still teach it if you want, but it's not necessary. And also what's been moved from stage 4 is line and rotational symmetry, translations, reflections, and rotations on the number plane. And this is so that it can be taught in context of transformations of graphs. Yeah. Anything to add, Klaas?
No, I like the last point, the line and rotational symmetry, and especially the translations, reflections in the X and Y axes and rotations with the multiples of 90 degrees.
Mm.
I think students will find that interesting.
Yeah, it'll certainly help them with their transformations of functions, because it was a new topic. It's a new topic in senior maths, in the advanced and extension courses, and at first, teachers and students were struggling with it. So there'll be a bit more background in stage 5 now.
Just go back again, Robert.
Sure.
The last part of the core, the equations of parallel and perpendicular lines, that'll be difficult for some students, I think.
Yeah. Yep. So it's important to not think of core as stage 5.1 anymore.
No, it's just
it's
core.
Actually, well, like it said, middle of stage 5, they're calling it. Okay, now we come to the nonlinear relationships, the curves, graphing curves. So, okay. So what's been removed from the core? Graphing circles. Those students, your average student doesn't need to know what the equation of a circle is.
No.
And your advanced student only really needs it when they're being introduced to the trig functions and the unit circle. So what's core is graphing quadratics, simple quadratics, and exponentials, and also applications of them. And then what's path? Oh no, it's still. This should
still core.
Actually, this should say path. So
path, yeah.
Okay, so that's a mistake there, which I'll fix. This should say path because it's an advanced path. It's called nonlinear relationship C. So harder parabolas, okay. The full parabola, y equals ax squared plus bx plus c. Harder exponentials, and you can see the transformations that are happening here now. Graphing hyperbolas and circles of center 0, 0 or AB. Points of intersection of a line and these curves using simultaneous equations. Graphing cubics. Now, this is, we don't teach this intercept form of the cubic anymore. It's been taken out. And then also graphing higher power functions. So this is really heading towards year 10 option type work. Okay. And then finally, we've got numbers of any magnitude. Now, this used to be part of measurement and geometry, but now that I think about it, it's called numbers of any magnitude, should be part of number. So, so these are the things like significant figures and scientific notation, and measurement with very small and very large measurements. But what's been taken out is digital memory, so from kilobyte to terabyte. I don't know why. I mean, you could teach it as an application of the metric prefixes 2 lines above it. There's no harm in teaching it. And also the instead of saying limits of accuracy of a measuring instrument, we now say precision, which is actually a more precise term. So they've got it right. And then what's new is absolute error and percentage error of a measurement, which is also in HSC math standards. Yeah. Okay. Oh, we're still in number and algebra. Okay, so
there's a lot.
Variation and rates of change. So the syllabus used to call this direct and inverse proportion, but they've updated it to variation. I mean, I use the 2 terms interchangeably anyway. So that's a path for standard and advanced, because it's also covered in standard as well. And then the advanced path is graphing rates of change, constant and variable rates of change, the phrase increasing at a decreasing rate. So this is like pre-calculus stuff, looking at concavity and gradient and stuff like that, and distance time graphs, which is travel graphs with variable speed. Yeah, anything to add, Klaas, before we move on to next one?
No, I like the fact that they talk about the increasing and the decreasing rate part. The second last dot point.
Yeah.
I think that's really important.
Okay. we still haven't got to these, what we used to be the old stage 5.3 option topics that we didn't have time to get through. And hopefully in the new syllabus, we'll have time to get through. So we've got the polynomials topic for extension students, and we've got the logarithms topic for advanced students. And a new thing we've got here is logarithmic scales, which is also taught in HSC Maths Advanced now. So it looks like this. In case you don't know, a base 10 logarithmic scale, numbers go up by powers of 10. And you might have noted, like, these are really popular during the pandemic when they were trying to graph the number of cases worldwide or in a country, because it really shot up. So in able to fit those big numbers in, they had to resort to a logarithmic scale. And then these exponential logarithmic equations are here, types of equations that you might have to face. And then finally, I think, functions and other graphs. So domain and ranges becomes a formal terms, and also graphing regions in the number plane has come back into the syllabus. I think after 20 years, maybe, I don't know. It's been a while.
No, after 10 years, I think. It used to be before, yeah.
Okay. All right, so let's have a look at measurement and space now. Okay, so we're in stage 3 now, and geometry. So we've got the number plane, length, perimeter, angles, and what's been taken out, vertically opposite angles, and also grid references on maps. 2-dimensional spatial structure. So that's anything in 2 dimensions. So it's triangles, quadrilaterals, and polygons. And it's also looking at area of things. And it's what's been taken out, enlargement of shapes, parts of a circle, and combined transformations. And I can kind of tell why, because these are sort of things that don't lead to anything until you get into high school. So it's better for these things to be introduced in high school. But polygons is new though.
Yeah.
3 dimensions is things like solids, so prisms and pyramids. However, what's been taken out is faces, vertices, edges of a solid, nets of solids, measurement, 3D measurement, so it's capacity, volume, and it's also, what's new is volumes of irregular solids by displacement in water. Okay, non-spatial measurement is things not to do with space, so it's maths and time. So what's been removed, gross versus net maths and timelines. But everything else there is covered in years 5 and 6. Okay, now we're in stage 4. So you'll notice there's nothing much has changed. I've got a diagram there of an L shape. Now, how do you find the area? Now, how do you find the perimeter of this L shape? Now, some of us, when we teach this, we teach shortcuts. And it turns out that the 4 and the 5 there don't actually matter what those lengths are, because you can move the 5 up to the top there, and you can move the 4 to the side there. So it just becomes a rectangle. So it's like 2 times 12 plus 2 times 10. So the answer is 44. So we've got circumference of a circle, we've got arc length, we've got perimeter of a sector, and we've got Pythagoras' theorem. Okay, area and volume, if you look at that, it's what we're currently teaching anyway.
Yeah.
Okay, big thing is that time has been removed. So time calculations and time differences have gone to stage 3, and international time zones has been removed altogether. Now, someone told me it's in the geography syllabus or the science syllabus, but I would still teach it in maths anyway, because there's applications of time zones when you do the time calculations. So we've, what have we done? We've kept it in our books as either extension or revision, because time calculations and time differences is revision, and international time zones is extension.
And it's also part of the standard course in year 11 and 12.
Yeah, that's right. In year 11. Yeah.
So now the time calculate, all of that is in the year 11 standard course. Yeah,
actually, you're right. Yeah. And the funny thing too is that the Australian curriculum has just introduced time zones. Yeah. So I was going to say this later, but you'll find that with syllabus change, It's cyclic. So things go out of fashion and then come back in. So we're at this point now where New South Wales and Australian curriculum are sometimes the opposite of each other.
Out of sync. Yeah.
And out of sync, yeah.
Yeah.
Yeah, you'll see that in a few pages' time too when we talk about congruent and similar figures. Okay, so we've got angles. Nothing has changed much. I remember when I started teaching, we did teach what array was. And array, well, array is like half a line. It's got a point on one side and it's got an arrow on the other side. But we use it to describe the arms of an angle. Okay, properties of geometrical figures. So we're still in stage 4, so it's geometry. So line and rotational symmetry has been taken out. It's been moved to stage 5 path, but it was also in stage 3. So you could teach it as revision if you wanted to. Triangles and quadrilaterals, nothing new there. But however, congruent figures, including the congruent triangle test, have been moved out of stage 4. It's actually gone, it's not even core anymore. It's stage 5 path.
Yeah.
So all that harder geometry is now non-core. I know some teachers will be cheering about that, and then there'll be other group of teachers who will feel sad that that's happened. But I don't have an opinion either way. But the funny thing is the Australian curriculum has gone the other way and put congruent and similar figures back in year 8.
Can I bring up an interesting point, Robert?
Sure. Yeah.
When I was a student in high school in year 7, we did congruent figures and the congruent triangle tests. That was when I was in year 7.
Yeah, I know. And I think and when I was teaching, I would always put congruent and similar figures at the end of year 8 in the teaching program because I knew that we would never get to it.
Yeah.
And then they'd learn it again in year 9.
Yeah.
Because they would learn it again in year 9. Yeah. Okay. Now we come to stage 5 in trigonometry. So remember that slide I showed you before. So trigonometry A and B is core, and it includes true bearings. And what's new is compass bearings have come back in. Now, if you weren't teaching 20 years ago, we taught this 20 years ago, compass bearings.
Right.
So the compass bearing of this angle here is south 30 degrees west. So the bearing is always an acute angle from north or south going towards east or west. So it's either north something east, north something west, or south something east, south something west. I thought it was taken out of the syllabus like 20 years ago because it was no longer relevant, but I don't know. No one's told me whether these types of bearings are still used in real life. Or is
I
it
know
just
true bearings are.
Yeah. Okay.
Yeah.
Okay, so next is trigonometry C, which was stage 5.3. So this is pretty challenging stuff for students heading towards standard. So it's 3D problems, sine and cosine rule, and the area of a triangle. Okay, trigonometry D is nothing's changed there. The sine rule ambiguous case is covered here as well, but not for standard. So we've got things like angle of inclination of a line, m equals tan theta, which my son was doing last night for homework, actually. So yeah, it's pretty challenging stuff there. Okay, area and surface area, what's core? It's only rectangular and triangular prisms we do surface areas of. Oh no, sorry. And also then we go on to nets of prisms and surface areas of, prisms, cylinders, and composite solids. That's right. Now, what's path is pyramids, cones, and spheres. Now it says there it's for standard path, but when you look at the standard course, it doesn't even go this far. So I would say either don't need to teach this to standard students, or perhaps this is going to be in the new standard course when they revise the syllabus in future.
Mm-hmm.
So I don't know. Okay, but it could go either way, I guess. Okay, volume. So volume A is core. So again, prisms, cylinders, and composite solids. And then volume B is path, pyramids, cones, and spheres. Okay, we're still in stage 5 core geometry. And I've written that comment that there's not much there in the core. So it's basically similar figures, scale drawings, and there's a new similar to symbol, which is like the squiggly line instead of the 3 vertical lines.
Yeah.
I don't know, Klaas, have you seen that before?
I have actually, yes.
Yeah.
Yeah, but I've never used it. So I've always used the 3 vertical lines, but I have seen it in books.
Okay. Might be in a different country maybe then. Okay, and then it goes straight to path. And this is all the geometry path work is actually for extension students. So you've got your congruent and similar triangle tests and proofs. You've got areas and surface areas and volumes of similar figures. And you've got the angle sum and exterior angle sum of a convex polygon. And then in path D, geometry C, you've got the proofs, you've got the test for quadrilaterals, and you've got formal and abstract geometry proofs. And then you've got good old circle geometry, which nobody thought would still be around in 2023. But it's still there, but it's there for, I think it's there because it's extension work. It's interesting work for students to broaden their mind in geometry.
And it also develops their ability to reason, I think.
Yeah.
I think that's pretty important, reasoning and the order in which things have got to be given.
Yeah, there's not many applications of circle geometry in extension 1 and 2 maths, other than some vector proofs. But I guess doing geometry will help students improve their reasoning and proof skills, which is required in extension 1 and 2. So that's probably why it's there. I answered my own question.
Yeah.
Okay. Oh, and introduction to networks. So, which is also new to the Australian curriculum. So you'll see that these are the very basics. Now, when I was when Klaas, I know you wrote in the standard year 12 book, you wrote the chapter on networks, and it was a long chapter. And I remember when I was reading it, it would be really good to have some of this stuff in year 10 for students to learn, because a lot of introductory stuff could be covered in years 9 and 10. So here it is. I think NESA have worked it out, or Australian curriculum writers have worked it out. So it's here. So and in this, I like this topic because they don't learn the algorithms, the methods. They just play around with the networks. So everything's by trial and error, and it gets them used to the terminology and the parts of a network, and also Euler's formula, which is not covered in year 12.
No.
And it gives them more time to explore.
The planar graphs is not covered in year 12 either. It's not referred to as planar graphs.
Yeah, that's right. Yeah.
So that's a new term as well.
So this is a good example of routine and non-routine problem solving, because students have to work it out themselves, and they have to talk about it as well. So that's your communicating and reasoning there. So it's good. Okay, now we're up to statistics and probability, stage 3. So nothing unusual there other than dot plots have been removed.
Oh, that's a relief.
And then comparing displays, including the shape, the mode, and the range. That's pretty high concept. So
yeah,
I guess good luck with that. And then chance, A and B, nothing different there either. And then stage 4, okay, a few new things, but everything else is the same. Okay, in categorical data, there are 2 types, nominal and ordinal. And that was also introduced to the HSC Maths Standard course as well. So there's 2 types of categorical data. There's nominal data that are just names and cannot be ordered. And there's ordinal data which can be ordered. So the syllabus gives blue, green, yellow as being nominal, and small, medium, large as being ordinal, because you can put them in order. Okay, data analysis. Now, this was a big thing. I asked NESA about 3 years ago, when are you going to change the name measures of location? Because no one else uses it outside New South Wales. And also in stage 6, we call it measures of central tendency. So we should call it measures of central tendency. And they said, okay, we'll think about that and we'll get back to you. But they've come up with measures of center. So that's the new terminology. The Australian curriculum, however, uses measures of central tendency. Now, what's been taken out is statistics of samples versus population, sample sizes, sources, and ethical issues, which I think was quite technical and high highbrow for
Yeah.
stage 4 students. But what they've put in here, which I think is also equally highbrow, is the shape of a distribution. I guess it's pretty high concept for stage 4, but I guess there's these pretty diagrams here that students can learn to understand what they mean. So it's looking at the shape of a distribution, understand what skewness is, what bimodal means, and also the location of mean, median, and mode here on these diagrams, which are quite hard to understand.
Did they give a diagram to show bimodal in the syllabus?
Yeah, they did.
They did. Okay.
Yeah, they did. Okay, and then stage 4 probability. I guess the big change is it's been shortened. So Venn diagrams, two-way tables, mutually exclusive events, compound events, all that has gone to stage 5 and it's path. So it's been taken out of core. So you can, in stage 4, you can just concentrate on basic probability and also experimental probability, and also simulations is new.
Yeah.
Okay, stage 5 core. There's a lot of data here that used to be 5.2, 5.3. So it's I said it's quite ambitious for stage 5 core, but it's all covered in Math Standard 2 as well. So I guess that's why it's here. So standard deviation is everyone does this now. Yes,
yeah,
Klaas.
and you think it's just a calculator exercise, isn't it?
Yeah, I guess so. Yep.
In the end, but they need to understand what standard deviation means, what quartiles mean, but they can use a calculator.
Yep, I guess so. Yep. So it's very conceptual. But I guess they're trying to beef up the data analysis because our world today is all about data. So we need to be good statistical consumers. So even the bivariate data and the scatter plots and the line of best fit by eye and what is it, correlation versus causation, or as they say here, association versus causation, like that's all considered core now. What was 5.3 is now considered core. Now, and then you've also got this path. What's new is conducting a statistical inquiry and evaluating statistical reports in the media. And then when you look at probability, this is stage 5 core. So we've got dependent and independent events. We've got tree diagrams. But what's new with tree diagrams, we've actually got the tree diagrams with the probabilities on the branches that you usually don't do until stage 6. So that's new, as well as probability simulations. And that's core, which is good because that's all you have to cover over years 9 and 10 in probability. And what's advanced are the Venn diagrams and the two-way tables and the conditional probability and the compound events. So it's a smaller probability. So just to summarize what I said before, syllabus change is cyclic. Don't throw away your old worksheets and textbooks because things will become new again. Class, the very first edition of New Century Maths in 1995. What was one of the option topics was networks.
Networks, yeah. And I've thrown out that book.
Yeah, well, but David Badger still had it, so
yeah.
He keeps everything. So I got a copy of that chapter for you. Okay, so it's basically a more rigorous core in stage 5 overall to provide flexibility and encourage aspiration. I guess almost all of stage 5 statistics is core now, but Venn diagrams and two-way tables are now stage 5.
Yeah.
Path advanced. So more statistics, less probability, and also less geometry overall. All the harder geometry has gone to the extension path.
Yeah.
Okay. So we've been busy updating our textbook, and these are the changes. So New Century Maths 7, no change to the chapter names, but just subtle changes to the content. New Century Maths 8, there is no longer a topic called congruent figures, and time has been taken out for chapter 10, so it's just ratios and rates. Okay, so in our year 8 books, however, and in our year 7 books, we still have some extension work for those students that are to extend students, and sometimes it's stage 5 work. So you'll see here, we've got some stage 5 work in the year 8 book. Okay, Year 9, we're still going to continue with like a standard Year 9 book and an advanced Year 9 book. And the standard Year 9 book will just cover all the core and the paths that are required for Maths Standard 2. Yep. So what's new is that geometry now becomes geometry and networks, and congruent and similar figures is now just similar figures. And then on the right-hand side is all the core and all the paths required to head towards advanced. So anything that's red there is an expanded topic to the ones on the left. So the advanced pathway has less revision and more harder questions and harder topics, basically. So just to give you an example, chapter 7 of equations in the advanced book has all those things in red. So cubic equations, quadratic equations, changing the subject, and also binomial numerators in the algebraic fractions. And then chapter 13, congruent and similar figures, has all that work in red. So in our standard Year 9 book, it's just those 3 things on similar figures. Okay. And then chapter 10, the 2 pathways diverge even more. So what's different here? Chapter 6 is now just equations because there's no inequalities in the core. There's no simultaneous equations in chapter 9. So we've got a new topic called networks. No geometry. So we've also offered 4 bonus option chapters at the end, 11 to 14, which we have in our current books. And then in the advanced book, everything's red there other than interest and depreciation, because there's interest and depreciation is all core. But everything else is the entire course, I guess. And then we've got option chapters for maths extension 1 at the end there, functions, polynomial, circle geometry. And we've also even added networks for if you want to do it as an extension, like an interest topic, or if any students in your advanced class decided to go to Maths at Standard instead. So this is what a page looks like from our current books. And the things to notice here is that the questions are color-coded in order of difficulty. So foundation, standard, and complex. And we've also got these markers here that indicate when you've got a problem-solving, reasoning, and communicating question. We didn't label understanding and fluency because every question is understanding and fluency. Yeah. Klaas, anything to add?
No, it looks good, Robert.
Klaas?
I like the new syllabus. I'm liking it more. The only thing that people have to learn is to navigate through the syllabus, to tie the 2 different things together at
there's
times.
a lot there.
Yeah. It's a long document.
Yeah, it's not linear unless you downloaded it on a PDF. Yep, there's a lot to see here. Now, if you want a copy of this PowerPoint, I've got a link here for you to type in and download. And I've also left my email address in case you have any further questions. But get in touch with us either through the New South Wales sales team. They've got things like, we haven't developed full teaching programs yet, but we do have scope and sequences, and we have got draft table of contents if you're interested. So thanks for joining us today. And maybe you can watch this video again or look at the PowerPoint at a slower rate so that you can absorb all of the changes. Klaas?
No, that's it. Thanks. Yep. Enjoy the new syllabus.
Yep. Have a great day, everyone.